In this problem, we have the electric field, which is equal to this is the quantized electric field, and we are asked to find out the expectation value of E, the expectation value of E square, and this thing. So first of all, if I write the expectation value of this for the number state, so we have the number state this and this, and this is the value of E. Because if we take the expectation value for any, for example, the expectation value for X, so we can write this as it is integration and some state and x and psi and in a one dimension dx. So in a Dirac notation, we can write this as psi, x and psi. So in here the state is the number state, so we have considered the number state here, the number state here, and x in term of E field. So this is the E field we have considered. Now we can take this term, and this term take out uh, outside from this relation, and we can only have the annihilation operator and the creation operator. Now this is equal to 0, because if we apply the annihilation operator on this state, then we have a n, so we can get n and n minus 1. So this is the eigenvalue. And if we take this state with this n, n is the eigenvalue, and we have n minus 1. So this goes to 0. And similarly, we have this term also goes to 0. And finally, we have the expectation value of E, which is equal to 0. And similarly, the expectation value of E square. So we can take the E square. If we take the square of this, then we can get this square, the first term square, this square, this is the multiplication with this, and this is the multiplication. So we have four terms, and the first term is this one. The second term, if we multiply this with this, so we have the exponential term will cancel out, and we only have the operator a dagger. And if you multiply this with this, so we can get a dagger a, and multiplication of a dagger square. So we have a dagger, and this. Here, if we this term, the annihilation term, if we have annihilation term, this initially this will be equal to 0, because already we have done this. This and the last term must equal to 0. And the survival term is this one and this one. Because if we apply the a dagger on n, then we can get like this. If I consider a dagger apply on this, then we can get n plus 1 under root, and this n plus 1. And further, if we apply the annihilation operator on this, we have the annihilation operator as this n plus 1 already we have, and n plus 1, and one term will be reduced, so n. So we can get this term and this term, and we have the state this. And if we apply annihilation operator first, so we can get n under root, and after we apply the dagger, so we have the eigenvalue this, and the state is this, and this is equal to 1, and this is equal to 1. And then we have e squared to n plus 1, and because n plus 1, so we have n plus 1, and then we can get, if we simplify this, these two terms, then we can get 2n plus 1, and if we take common 2, then 2e square n plus 1 under root. And finally, we are asked to find out this thing. So this is the expectation value of e square, and we know about this, the relation e square average minus E average square. And we already know about this term. We have this one, and this term is equal to 0. So finally we have this answer of delta E square.